Hello everyone, in this video I'll be explaining on the introduction of fluorescent microscope. This fluorescent microscope is an optical microscope that uses fluorescence and phosphorescence instead of or in addition to scattering, reflection and attenuation or absorption to study the properties of organic or inorganic substances. Fluorescence is a phenomenon that occurs when an object is impacted by a given wavelength of light and emits light at a wavelength longer than the one to which it is exposed. Most cellular components are colorless and cannot be clearly distinguished under a microscope. This basic premise of fluorescence microscope is to stain the component with dyes. Fluorescent dyes, also known as fluorophores or fluorochromes, are molecules that absorb excitation light at a given wavelength, generally UV, and after a short delay emits light at a longer wavelength. The delay between absorption and emission is negligible, generally on the order of nanoseconds. Emission light can then be filtered from the excitation light to reveal the location of the fluorophores. This uses light of a high intensity source which excites a fluorescent agent, which is in turn emits a low energy light of a longer wavelength that produces the image. The fluorescent light can be separated from the surrounding radiation using filters designed for the specific wavelength, allowing the viewer to see only that which shows fluorescence. Fluorescence microscopy uses a much higher intensity light to illuminate the sample. This light excites fluorescence species in the sample, which then emits light of a longer wavelength. The image produced is based on the second light source or the emission wavelength of the fluorescent species rather than from the light originally used to illuminate or excite the sample. In fluorescent microscope, specimens are exposed to a light of shorter wavelength, which results in emission of longer wavelength, that is, of visible light. Light of the excitation wavelength is focused on the specimen through the objective lens. The fluorescence emitted by the specimen is focused on the detector by the objective. Since most of the excitation light is transmitted through the specimen, only reflected excitatory light reaches the objective together with the emitted light. Microorganisms in a specimen can be stained with a fluorescent dye. On exposure to excitation light, organisms are visually detected by the emission of fluorescent light by the dye with which they are or they have been stained. Bacteria stained with fluorescent dye becomes visible as brightly glowing objects in a dark background or against a dark background. There are types of fluorescent microscope includes fluorochromy and immunofluorescence. Fluorochromy involves the non-specific staining of any bacterial cell with a fluorescent dye. Immunofluorescence, while immunofluorescence, this uses antibodies labeled with fluorescent dye to specifically stain a particular bacterial species. So this is the introduction of fluorescent microscope, which is also an optical microscope.